Hello everyone and welcome to this next video from the series called Modern Identity powered by Azure. In this video, we are going to talk about granular authorization in cloud apps with OpenFGA hosted on Azure Container Apps. In this video, we will not only talk about different kinds of authorization types, but also we will discover open source authorization solution provided by Auth0 team called OpenFGA. We will see how to host it using Azure Container Apps and then how to handle authorization from the Blazor web application perspective. So let's start. Before we jump into details, I think it's worth to talk about authentication and authorization, because in the end there is always some confusion. So let's clarify the difference between those two. So when it comes to authentication, authentication verifies the identity of a user or the service, so verifies who a user or service is. Once user is authenticated, applications know user's identity. In the OIDC OAuth world, once user is authenticated, ID token is returned to the application. For example, when logging into Azure Active Directory, the process in which Azure AD verifies the user's username and password are correct is authentication. On the other side, there is authorization. Authorization is the process which determines if a user can perform a certain action on a particular resource. For example, once the user is authenticated with Azure AD, checking whether user can access specific documents on the SharePoint side is authorization. In the OIDC OAuth world, once user is authenticated, access token is returned to the application to be used when sending the request to the protected resources like web APIs. Now, there can be different approaches when it comes to authorization, different kinds of authorization types. So let's discuss them briefly. So first authorization type, it's called role-based access control or RBAC. So for those of you who probably work with Azure Cloud, for instance, you are familiar with RBAC, yes? So you have different roles, and then based on those roles, you can assign different permissions to access resources in the Azure Cloud. In the role-based access control, permissions are assigned to users based on their role in a system. For example, a user would need an editor role to edit posts. So to edit specific post in the system, in the application solution, user has to be granted editor role. And once the editor role is assigned to the user, this user can edit posts. And basically, we can have different kinds of roles like global administrator, reader, writer, and so on. So this is, I would say, the most popular system when it comes to authorization. On the other side, there is attribute-based access control or ABAC. In attribute-based access control, instead of permissions being granted based on roles, they are granted based on a set of attributes on a user or resource. So let's put some example here. If a user has both marketing and manager attributes, they can publish and delete posts that have a marketing attribute but not others. So you can try to imagine that if we have application solution in which you can edit posts, in this specific application, when user is authenticated and user tries to edit the post, then there is this check. Okay, so let's see if this specific user has marketing attribute. And let's see if this specific section that user is trying to access is related to marketing or editing posts. So if this specific user has the marketing attribute assigned or manager attribute assigned, then it means that in the context of posts editing, this specific user can edit those posts and also delete those posts. And the last type is called Relationship-Based Access Control, or RBAC. RBAC allows expressing rules based on relations that users have with objects and that objects have with other objects. So, for example, a user can view a document if they can view its parent folder, or users can edit document if they have writer relationship specified for specific document. So in this video, basically, we will talk and focus on the relationship-based access control. Perfect. So right now, let's move forward. Let's talk a little bit about authorization approaches. This is always a hot topic when there is discussion about authorization. Like every time I remember from the past, when implementing identity systems, there is this conversation. Okay, guys, how we are going to approach authorization implementation in our solution. So let's discuss some ideas here. So the very popular, like the most popular approach is token-based authorization. So let's focus on that first. This is like a typical scenario where user has access to a specific application, let's say single page application, and there user can authenticate. So obviously user is redirected to the authorization endpoint of the identity provider. User provides set of credentials, and then once user is successfully authenticated, the set of ID token, the set of tokens like ID token and access token is returned to the application. And then from this application, user or this application can call Web API protected resource on behalf of authenticated user. And to call this Web API, there has to be access token attached to the authorization header. Perfect. So right now, when it comes to token-based authorization, let's see how authorization is handled in this approach. So let's look into the tokens content. But before that, let's focus on this typical scenario. So to implement token-based authorization, obviously we need to specify the authorization data that will be included in this token. So let me put an example with Microsoft Entra Admin Center and Azure Active Directory, to be more specific. So in the Azure Active Directory, you can specify something that is called app role. So you can say that specific user has specific role in the context of specific application. So as you can see on the top left screen, there is a writer app role, yes, and writers have ability to edit posts. So once this app role is added, and user has this specific app role assigned. So in this case, as you can see, there is Daniel tester user and assigned role is writer. This specific user can do something in the application because of the fact that information about this app role will be included in the token. So let's look at the token content. Let's look into the token content to be more specific. So as we can see, this is the decoded ID token that was returned from the Azure Active Directory once the writer role was added for Daniel tester. So as we can see under one of the claims, which is called roles, we can see that there is writer role. So right now with this information, we can build authorization on the application side. So to put a simple example, we can say that, okay, this specific user will have access to this specific functionality of my application under condition that in the token under the roles, there is a writer role. So let's say that in your web application, you have the place where you can edit posts for any reason, yeah? And to make it possible for the user to access this section and basically to be able to modify the post and to modify, like update the post, save it, and so on, this user has to provide this information about the role. And this information is included in the token. So as you can see, there is writer role. So application will look into the token, will check the roles claims. If writer role is there, okay, this specific user can edit and save posts. But there are pros and there are cons of such a solution and such approach. So let's discuss the pros first. We can manage groups directly from identity provider like Azure Active Directory. Yes. So in this case, to be more specific, we can manage roles, groups, and basically authorization from the identity provider perspective. So as we saw on the previous slides, we can create a role, then we can assign this role or group to the specific application, then include this information in the token like ID token or access token, and then applications will look into the token content and decide whether a specific user is authorized to access specific functionality or not. We can include the authorization data in the token, so it's available to the application immediately after user authentication. So yeah, this is the pros and big advantage. Yes, like authorization data is immediately available for the application, for the resource, once user is authenticated. We do not have to implement additional layer of authorization checks in the applications. That's another big advantage. Yes. Application will only have to look into the token's content and decide whether a user is authorized. But there are some disadvantages of this approach. One of the biggest disadvantages is that authorization data can change and then be stale in the tokens. User role was removed, but token is still valid. So there is no real-time authorization data update. So you can try to imagine the situation when, let's say, a specific user has writer role assigned in the Azure Active Directory, for instance, and this information is included in the token returned to the application. So now application is verifying the role claim in the token. Application sees that there is writer role, and then application authorizes the user to access specific functionality. Perfect. But let's say that for any reason we decided to change the role for this user from writer to reader. This is the problem. Obviously, on the Azure Active Directory side, we could change this app role, and now user will have a reader role, but information in the token is still valid because of the fact that token is valid. So then application does not receive information that authorization data has changed. So even if we are updating the authorization data for the user, those changes will be reflected only when there will be token exchange, or when the token will be either refreshed or when the user will re-authenticate again. So it's problematic, yes? So we can end up with stale authorization data in the tokens. Another disadvantage is that the storing granular authorization data can increase token sizes. So tokens can become large, and basically this is a big problem, because if they will be large, it can be nearly impossible to store complex granular authorization data in the tokens. So in this case, when we talk about roles and few roles that can be assigned to the user, that's fine. And for some scenarios, token-based authorization can be good. I'm not saying like it's bad approach, never use it. I'm just saying that it has advantages and disadvantages, and I want to present them to you. And also say that when you really want to implement granular authorization, this is not the way to go. So now, let's talk about global authorization system-based authorization. So previously we talked about token-based authorization. So we talk about putting authorization data in the token. But right now, the other approach we are going to discuss is global authorization system-based authorization. So let's talk about the details. Such global authorization system-based authorization enables granular complex authorization implementation. So that's a big advantage. We can really implement complex authorization model and then use it in our application solution. Applications and APIs authorize users against central authorization system. So this is one more different approach and an advantage of using this specific solution. So all the applications and APIs authorize users against a central authorization system. So there is a central place where we keep authorization model, where we keep the relationships between users and objects, and then applications and APIs can use this authorization system to decide whether users should have access to specific functionalities. There is always fresh authorization data used by the applications. That's a big advantage of this solution. So as you remember, I mentioned in the token-based authorization, we can end up with stale authorization data in the tokens. In this situation, there is nothing like this, because every time a user is trying to access specific functionality or section of the application or specific resource, there is authorization check against the authorization system. So there is always fresh authorization data. If we update the authorization model or relationship between user or resource, then this will be immediately reflected. This requires more work on the application side to integrate securely with a global authorization system API. So I'm not saying it's trivial, because it's not. That's why very often there is this conversation about token-based authorization, like, okay, let's include some authorization data in the token and let application just access it and easily validate whether user is authorized or not. So this approach requires more work on the application side. So more implementation, because we have to adjust applications and APIs to be able to securely talk to this authorization system API to check whether user is authorized or not. Implementation of such global authorization system is not trivial and can be challenging. So that is why it's worth to look into the market to see whether there are some ready-to-use components or solutions. And one of them is OpenFGA, which we are going to talk about in this video. OpenFGA is an open source authorization solution that allows developers to build granular, relationship-based access control using an easy-to-read modeling language and friendly APIs. It was created by the AuthFGA team and was inspired by Zanzibar, Google's consistent global authorization system for determining whether online users are authorized to access digital objects across their products, like Google Drive, YouTube, or Google Photos. So that's really interesting, because OpenFGA was inspired by authorization system that is used by Google in the products like YouTube. So if you ever sign in to YouTube and you try to access different functionalities, underneath Zanzibar is working, so this global authorization system. When it comes to OpenFGA, it offers an HTTP API and has SDKs for programming languages, including Node.js, JavaScript, Golang, .NET, and Python. More SDKs and integrations such as Rego are planned for the future. In this video, we will visit official documentation for OpenFGA, which is available under openfga.dev. Perfect. So right now it's time to connect the dots and see it in action. Let's start with OpenFGA documentation, which is available under openfga.dev. Once we visit the page, we can click Quick Start button. And then there is information how to launch OpenFGA using Docker container. So as we can see, we have to pull the image from Docker Hub, and then we have to run OpenFGA locally. And if we open Getting Started section, we will see that here under Setup OpenFGA, there is information how to set up OpenFGA with Docker and Kubernetes. So let's focus on Docker. As we can see here, there is information what is required. So first of all, obviously we have to install Docker locally if it's not already installed. Then we have to pull the latest image for the OpenFGA, and then we can launch OpenFGA on the local host. And it's worth to mention that we are exposing 3 ports. So this first port, 8080, is responsible for HTTP communication with OpenFGA API. 8081 is responsible for using gRPC, communication, and port 3000 is responsible for exposing Playground. So when it comes to Playground, I will show you something about it, but Playground is basically the place, the web application which you can use to model your authorization data and then play with it. So we will see it in this video. Okay, perfect. So basically below there is explanation what has to be done, some best practices, how to configure the server, how to configure the data store. So please remember that the memory storage engine is the default one, but obviously data is not persistent. And we can also use Postgres and MySQL. So in this video, I will show you how to use OpenFGA with Postgres database hosted in the Azure cloud. Perfect. So when we scroll down, we can see the information how to configure OpenFGA with Postgres database. So first we have to create the network. So we have to use the command .NET network create OpenFGA network. Then we have to create the database within this network, the Postgres database. So there is a command how to do it. And then we have to do the migration. Yes, it's very important to mention that before we can start using of OpenFGA, we have to create OpenFGA database and create required tables that we will see in this video. So that's why you can see here that there is this migrate command used with the data store URI, which is Postgres, to create the tables. And finally, we can start OpenFGA on the local host using Docker. So here is the command how to do it. And as we can see, this will start the Postgres database, run OpenFGA migrate to configure the database, and finally start the OpenFGA server. So please remember about this OpenFGA migrate command to make sure that the tables structure is created first, and then you can start using OpenFGA. But I will show you this in my database I created. Perfect. So once you start the OpenFGA, you can create authorization store. Yes, and we will discuss it in a minute. But before that, I want to show you the database structure I created. So really quickly, let me open Azure Data Studio. So this is the tool that I use to connect to my Postgres database in the Azure cloud that I created, and I will show you that in a minute also. But you can see that here I have OpenFGA DB, so the database created for OpenFGA. So it's required to be created first before you start using OpenFGA. And as you can see under the tables folder, you can see all the required tables used by the OpenFGA. So for instance, you can see here that I have this public.store table that stores information about the authorization store. So here are my test authorization stores, as you can see. And also under the specific authorization store, we can create authorization model. So if I select records from the authorization model table, you will see that also I have some authorization model data here. And obviously, what I also have here, I have this table called tuple, and we will discuss tuples in a minute. But the case is that once we create the authorization model, then we can create those relationships between users and objects. So in this specific video, we will talk about relationship between users and documents. But anyway, we will get back to this, but I wanted to show you that. So once you create OpenFGA DB, you have to use migrate command to create all those required tables, and then you can launch OpenFGA on the local host. So when it comes to this video and when it comes to this example, I decided that I would like to host OpenFGA fully in the Azure cloud. So that is why, as you can see, here is my Azure cloud portal and resource group where I created Azure Container Apps environment and one container app with OpenFGA. And also I created a PostgreSQL database that will be used with OpenFGA. So in this case, it's really important to mention that you have these multiple options to choose where you want to host OpenFGA. In this specific video, I decided that I would like to host it in the Azure cloud with Azure Container Apps. So that's why I will discuss it in a minute, this configuration, how to do it. But also I decided to use Azure database for PostgreSQL single server in the Azure cloud. But of course, if you are familiar with Azure cloud, you know that there is also flexible server and you also can use it with OpenFGA. So perfect. I will not cover how to create Azure PostgreSQL in this video because this is out of the scope, but please remember that it's quite easy. You can do it either with some scripting like Bicep or ARM or Terraform, or you can directly create Postgres database from the Azure portal. Yes, and here you can type Postgre and then select the right offering for you. Perfect. So I have those components created here. Obviously, I will also explain how this Azure Container App is created with OpenFGA. But just to summarize, you can play with OpenFGA locally. So you do not need any other infrastructure. You only need to install Docker on the local machine. You have to create this database, data store, using migrate command, and then you can start OpenFGA. Perfect. So once you create the OpenFGA, once you launch it on the local host, there are other commands and there is other explanation here in the documentation. So to interact with OpenFGA, obviously you can use API, but there is also a client SDK. So as you can see, there is Node.js, Go, .NET and Python. In this video, I will use .NET, and it's available. This package is available under NuGet, and you can just add it to your project, like .NET add package openfga.sdk. And once it's installed, you can start interacting with OpenFGA. So in the documentation, you will find explanation like how to create a store. So when it comes to authorization data, store is I would say the fundamental here, because once you can create authorization model, first you have to create authorization store. So the steps are like this. Configure OpenFGA as we explained before. Create a store for authorization data. Then create authorization model. Then create a relationship tuple, which we will describe. So the relationship between users and objects. And then you can perform the check. So then you can check where, let's say, a specific user is authorized to edit specific document. Okay, perfect. So I will show you how to configure OpenFGA SDK in the sample ASP.NET Core application. But before that, I want to also talk a little bit about the playground that is available for OpenFGA provided by Auth0. So just to summarize, when it comes to documentation, as you can see, there is information how to set up SDK, how to configure authorization model, how to update relationship tuples, how to perform check, what are the best practices. So we will talk about them. So there are different code snippets you can use to easily start integration with OpenFGA. Okay, perfect. So right now, let's talk a little bit about the playground that is available to model authorization data with OpenFGA. As you can see, it's called Auth0 Fine-Grained Authorization. It's available under play.fga.dev and Sandbox is used there. So this is basically the tool that we can use to model authorization data. And it's pretty cool because if you expand at the top this list, you will see that there are examples of different authorization stores, like authorization for GitHub, for G Drive, for Slack, for instance, yes, or custom roles. So you can learn about modeling authorization using this playground and those models here. So as you can see, for instance, for GitHub, there are different entities like organization, team, repo, and then we can have different relationships like member, owner, repo writer, repo admin, repo reader, and so on. So it's really cool because on the left side, there is this modeling language used for authorization data. So as you can see, the latest schema is 1.1. And there is information about all those objects and their relationships. So as you can see, for instance, we have type user, we have type team, then we can create relations. So define the member, and member can be user or team member. Yeah. Then we have the repository type, and those are the relationships, like define admin. So admin can be user or team member, maintainer can be user or team member, owner can be organization. So as if you are familiar with GitHub, you know that there are organizations, and under organizations there are repositories. And there is also reader, which can be user and team member. Yeah. So as you can see, there is whole structure. It's more advanced model. And on the right side, there is this cool graph, this previewer displayed. So we can see all those different relationships between, like objects in your authorization system between different types. And as you can see, we have also the concept that is called tuples. So this is I would say, the description of the relationship between different types. So as we can see here, there are a few tuples added, and let's explain the first tuple. So as you can see, there is a user Eric, and he has relationship called member with the object organization OpenFGA. So in this case, Eric is the member of the OpenFGA organization on GitHub. Below, there is another tuple, so another explanation of the relationship between types. So as you can see here, the user organization OpenFGA member, so member of the organization, is the administrator, repository administrator in the OpenFGA organization. Yeah. And then if we will see below, as you can see, here is the information, for instance, that Anne has reader relationship to OpenFGA repository. So she can read, she has read access to this repository. Yeah. And once we define those different kinds of tuples, then we can make assertions about those tuples. Yeah. So then we can check whether, for instance, specific user has access to specific resource. Yes. So in this case, we can here use those different kinds of assertions, yeah, to test what is happening when it comes to a relationship. Yeah. So as we can see here, we can also provide tuple queries. So I just want to really quickly summarize this, that it's really cool that before even writing anything in the code, what we can do, we can define this authorization model, yes? Then we can display this relationship or relationships between different types. Then we can check different relationships or permissions, you can call it like this, using assertions. And once we validate this model, then we can create authorization model using OpenFGA. Okay, cool. So I really recommend using this playground before even touching any source code, because then you can learn more. Obviously here you can click New Store, and once it's clicked, we can type the name. So here I will type this name for my authorization store. After a few seconds, sample authorization model is displayed to us. We have to click Save button to save it, and then we can start working and learning about this authorization model. So if we click Add Tuple, here we can specify those different kinds of relationships between objects in our system. So the tuple is this relationship statement. Yes, so let's see how to do it. As we can see, we have folders, users, groups, and documents in our system and in our authorization model defined. So now we want to say that user Daniel is the owner of the folder called folder 01. And we can click Save button. So right now, as we can see, I saved this relationship. So I'm stating that the user Daniel has ownership on the folder 01. So it's in the owner relationship to this specific folder. Obviously, I can define different kinds of relations here, but this is only the one, just for example. And then once we have it, we can add assertion. So here we can test these different kinds of relationships in our system. So let's say that I will add one more tuple here, and I will say that user Daniel, let's put it like this, and here is in the relation as viewer to the folder called folder 02. 02, yeah. Perfect. So right now we have those two tuples, those two relationships. For folder 1, I'm the owner, but for folder 2, I'm the viewer. So right now we can switch to assertions. So this is the place where we can test those relationships. We can validate them. So as we can see here, what we can define, we can make this assertion like, okay, user Daniel with the relation owner to the object, and let's check once again, user Daniel owner to the folder 1. Yes, so again, user Daniel owner, and here folder 01. Yes, and okay, and here I have to add folder. Yeah, so here we are testing whether user Daniel is the owner of the folder, and we can click Save. And I will explain this aloud toggle here in a minute, but as we can see here, I can execute the query. Yes, and once I do it, we can see this structure. So we can see that user Daniel is direct owner of the folder 01. So then above, I can test those different assertions here. So it's really cool because I can write those different assertions. As we can see, here are defined assertions. And I can say that, okay, check whether the user Daniel is the owner of the folder 01. Yes, whether the user is allowed to, for instance, edit or delete because of the fact that he or she is the owner here. Okay, perfect. So right now, as you can see, I can click Run All Assertions. And here we can see that this assertion passed. Why? Because user Daniel is the owner of the folder 01. But let's say that right now, I will say that user Daniel has, again, owner relationship, but, and again, folder 01, but now I will mark it to allowed to false. So right now I'm asserting that Daniel is not the owner of the folder 01, and I will save this assertion. Okay, there is some error. Let me really check it. So I will delete this one, and then I will save, obviously. So right now I'm stating that I think that Daniel is not the owner of the folder 01. Yes? And then I can run those assertions, and as you can see, assertion failed. So it means that Daniel is the owner of the folder 01. And this is really interesting because if we really have like a complex authorization model, we can easily validate what is happening when it comes to relationships. Yes, so it's really important to validate and make those assertions, because then we can quickly discover what is happening when it comes to authorization. So let's say that as a next example, we have different kinds of documents under a specific folder, and then we want to validate if multiple users have access to those documents in different relationships. Yes, so in this case we can write those assertions here, create those as I did here, and then we can run all those assertions and check. So it's really nice. So that's why I really recommend using this fine-grained authorization playground provided by Auth0, because this makes modeling much easier. Okay, perfect. So right now we can move forward, and right now I would like to focus on the OpenFGA in the Azure cloud. So here I would like to explain how to host OpenFGA in the Azure cloud using Azure Container Apps. Here is the Azure portal again and my resource group where I deployed OpenFGA using Azure Container Apps. So as we can see here, I created Azure Container App environment that will be used to host my different kinds of container apps. In this case, one container app with OpenFGA. So here, if I open this specific OpenFGA application, we can see that I will be able to access revisions. Yes, so versions of my deployments. So here we can see that I have one revision provisioned. So status is provisioned, it's running. So right now I can communicate with this OpenFGA instance in the Azure cloud. For those of you who are familiar with Azure Container Apps, you know that there are multiple options when it comes to accessing containers apps in the Azure cloud, and also isolating the environment. So for the demo purpose, I just deployed this OpenFGA component to the Azure Container App, which is available publicly. So I can just directly communicate to it from the internet. But obviously, you can also host it internally within the virtual network underneath that is used by Azure Container Apps environment. And then you can communicate with OpenFGA internally, yes, from other container apps that you host within the same container app environment. So here, if I click this, you will see that there is this revision URL that I can use to communicate with OpenFGA. Perfect. So right now I want to show you how to deploy OpenFGA to the Azure cloud. So as you can see, here I have the bicep file with the container app declaration and different kinds of parameters that are required to successfully start the OpenFGA in the Azure Container App in the Azure cloud. So as we can see here, first of all, I have those parameters. Obviously, I have to provide the name of the Azure Container App environment, the name of Azure Container App. So as we can see, as we saw, it had the OpenFGA prefix, the full path to the Docker image, the OpenFGA data store engine. So in this case, this will be a Postgre database in the Azure cloud, the OpenFGA data store URI, the OpenFGA log format, OpenFGA authentication method, OpenFGA authentication key, yeah, the suffix, revision suffix for the Azure Container App, yes, and information whether we want to use external ingress. In this case, it's set to yes, because we want to communicate externally with this container app. And also we have to specify the container port. And below, as we can see, here we have to provide and declare the container app environment. So if we get back to Azure portal, we can see that this is my Azure Container App environment. And then I have to declare the container app resource. So here, there I have to provide few details. Obviously, for those of you who are not familiar with Azure Container Apps deployment, there is a great documentation for using Bicep, so how to deploy this container app. But I want to describe this deployment process from the OpenFGA perspective. So obviously I want to set active revision to single, so only one instance will run one revision of this specific container app. And here under the secrets, as you can see, I have to provide OpenFGA data store URI. So this URI will link to the PostgreSQL database in the Azure cloud. And this is like a connection string where I have to provide the URI, username and password, and I will show you that in a minute. And also I have to provide OpenFGA authentication key. So in this case, it's like the predefined key that I use to securely communicate with my OpenFGA instance. So this is required when we will review the documentation of the OpenFGA. We will find those recommendations, yes, for running in the cloud. And there was, as you can see, there is information how to configure authentication. So if you use OpenFGA in the production, please be sure that you use it. There is also information that TLS should be enabled for OpenFGA server. So because of the fact that Azure Container Apps provide it, we can communicate with OpenFGA using HTTPS communication, but also we have to define those pre-shared keys to make sure that this communication is secure. So this can be found in the OpenFGA documentation. So let me get back. So here, as you can see, I provided those two values as secrets, but also, as you can see, I'm specifying that I want to use external ingress. So yes, I want to communicate directly from the internet with this container app. And I have to set the target port, which will be 8080, because as you remember, I want to use HTTP protocol to communicate with OpenFGA. So if we scroll down here, the important part is also about the command. This is really important. So it's not only about deploying OpenFGA to the Azure Container App, but also we have to start OpenFGA server. So those two commands are really important. So we have to type the OpenFGA and we have to start it by using the run command. So please do not forget about those two commands, because you can be surprised that you deploy OpenFGA to the Azure Container App and you will see that revision failed. And also under the environment variables, we have to specify a few environment variables. So OpenFGA data store engine, I will explain it in a minute. OpenFGA data store URI, so as you can see, here is the secret ref, so the reference to the secret I declared above. And we have to provide the log format, authentication method. So again, here we have to provide this parameter and pre-shared keys. So here, again, there is a secret ref to this specific parameter, this secret in our container app. So once I do it, I have also parameters.json file where I declared those parameters I explained a minute before. So as you can see, the environment type is production, but you can change it to dev. It doesn't matter, to be honest. It's about tags in Azure Cloud. Container app name will be this one. As you can see, CATMF MIP OpenFGA. The container image is the OpenFGA container image from Docker.io. The OpenFGA data store engine is Postgres. So in this case, we use PostgreSQL database in the Azure cloud. The OpenFGA data store URI is the URI that contains the address of the PostgreSQL database in the Azure cloud, together with the username and password. So it's really important to provide those, because then you will be able to communicate with the data store I showed you. Yes, so with this OpenFGA database hosted in the Azure cloud. Okay, perfect. Then we have to specify the log format. So JSON, OpenFGA data store authentication method. So we agreed that this will be pre-shared. So we will use the key here. And here is the pre-shared key value that I specified, and I will have to provide this specific key in the authorization header. And obviously the revision suffix will be 01 for Azure Container App. Container port will be 8080. So I will use HTTP protocol here. But please remember that at least at the moment of recording this video, you cannot expose multiple ports for Azure Container App. So in this case, only the 8080 port will be exposed. And also for the production scenarios, you have to disable the playground. So as you remember, if we get back to the documentation, I mentioned that under port 3000 there is playground hosted. So it should be disabled once you host the OpenFGA in production. So there is also information about it somewhere there in the documentation. So please remember to disable it. Yeah, it's really important. Okay, perfect. So in the end, I have to provide the name of my Azure Container App environment, and then I can successfully deploy this Azure Container App to the Azure Cloud. How you do it? Using Azure CLI, PowerShell, Azure DevOps pipelines, or GitHub Actions. It's your choice. In the end, in the Azure portal, you will end up with this environment and with this one revision for a Container App with OpenFGA. So once we have it, as I mentioned, under revision management section, we should see this information that this Container App was successfully provisioned, and it is, as we can see here. And right now, we can access OpenFGA under this URL. Yes, so we can copy it and use it. Perfect. So right now, we understand how to host OpenFGA in the Azure Cloud. So right now, I want to show you how to integrate with OpenFGA SDK in the ASP.NET Core Web API application. So let's see how to do it. Here is my solution in the Visual Studio. And as you can see, here I have Authorization API, ASP.NET Core Web API project. And obviously there are some other components because this is the bigger architecture here. But we will focus on the Authorization API. So here, under the core, I have Authorization here. And first of all, let's check the NuGet packages. So as we can see here, I have this OpenFGA.SDK NuGet package added to my project. Once it's added, I can configure OpenFGA. So let's see how to do it. So under the dependency injection, here I have this class called Authorization Service Collection Extensions. And here we have to get the OpenFGA configuration, which I will show you. And then under Add Authorization Services, as you can see, I'm adding OpenFGA as the singleton here. So here I have my configuration. So I have to provide the API scheme, API host, credentials, and then I can create new OpenFGA API instance, and then I can start using it from the OpenFGA Authorization Manager class. And I will show you that in a minute. But first of all, let's see the OpenFGA configuration here in the configuration file. Let me enlarge this a little bit. So we have to define the OpenFGA API scheme, which will be HTTPS. We have to define OpenFGA API host, which is the address I copied a minute before from the Azure portal. And here there is OpenFGA API key. So the key I declared when I created OpenFGA server, as you remember. So this is for the authentication. It has to be included in the authorization header when we will communicate with OpenFGA server. Perfect. And one more thing, this API scheme is important to be declared because as you remember, you can use HTTP, but also you can use gRPC. So in this case, we are using HTTPS API scheme. So once I have it in the configuration, I have to pass it here. So as you can see here, we have OpenFGA we have OpenFGA configuration. Yes, we have to provide the API scheme, API host, and credentials. So as you can see here, I'm defining API token as method for this credential, and under credentials configuration here, I'm passing the OpenFGA API key. And then every time I will communicate with OpenFGA server, this configuration will be used because of the fact that I'm creating the OpenFGA API instance with this configuration. So then I have this OpenFGA Authorization Manager, and let's look into this class. So under the services, I have OpenFGA Authorization Manager. And this is obviously like a proof of concept class, and in the future I will add more methods. But as you can see, I have this OpenFGA Authorization Manager interface, and here I have those different kinds of methods. Create authorization store async, create authorization model async, create authorization relationship async, and check authorization relationship async. So as you can see, this is exactly what I showed you in the OpenFGA documentation. Yeah. So here we have those different kinds of snippets, and then we can use them to configure OpenFGA SDK. So that is why here in the OpenFGA Authorization Manager, I'm injecting OpenFGA API client instance, and I can start using it. So let's see how to create authorization store. So I have this create authorization store async method. Here I have to provide the name of the authorization store. Yes, and then I'm using OpenFGA client that creates store, new store request. And here I have to provide the name of this store. Once authorization store is created, we will get the store ID. And this is very important to store it somewhere, because it will be required to then create authorization model or models under this store, and then to check, then to create relationships and check those relationships. So once the store is created, if you will open a database and public.store table, you will see that there are multiple stores. So here is my authorization store, MIP outs store. Yeah, and this store will be used with my authorization data. And here is the ID that is returned in the SDK. Perfect. Then we have to create authorization model async. So here I'm passing new authorization model request, and let me show you the definition really quickly. What's happening here? I have to provide the store ID, obviously, so where this authorization model will be created, under which store, and also authorization model schema here. And this authorization model schema is string value, and let me tell you why. Because here under configure authorization model in the documentation, for tests I use this simple model. So I have the type user, I have the type document, and then there are three relations, like user can be reader, writer, or owner. Yeah. And then in this sample, as you can see here for .NET, to create this model, you have to provide the JSON file, the JSON payload. So here we can use this DSL language to describe the authorization data, but then we can also convert it to JSON, and this is this format. So as you remember, this is why I mentioned that it's good to use this fine-grained authorization playground provided by Auth0, because once you define your model, yeah, let me zoom out a little bit. Once you define your model with this here descriptive language, then you can click copy as JSON, and then the authorization data model will be copied as JSON, and then you can directly send it in the request to your authorization API to create this authorization model. So right now, if I will, let me do it here. If I will paste it, you can see that here is the authorization model, but in the JSON structure. So that's why when we get back here, under authorization model schema, we can just paste this JSON. So it's really helpful. So I highly recommend using this playground to model your authorization data. Okay, perfect. So as you can see here, once we have this authorization model request, which is again this one taken from the documentation as JSON, obviously, then I have to specify the store ID. So I'm doing this here, and I can send here this authorization model. So I'm using OpenFGA client.write authorization model method. And here I'm using this JSON payload I sent to my API, which I showed you, yeah, in this structure. Once authorization model is created, then I can create authorization relationship, so tuple. So again, if we get back to the playground, you can see that here I have those different kinds of tuples. I can create them here, but also I can create them using the SDK. So let's see how to do it. Obviously here I have some validation, so you have to provide the store ID, you have to provide authorization model, which will be returned from the request that you sent to create authorization model. So if we open the database and we will select rows from the authorization model table, we will see that here is our structure. So there is a type user, document. Here we can even see some of those relationships like reader, owner, and so on. So here is our authorization model. And here is the ID sorry, this one, authorization model ID that we have to use. So then to define the relationship for the authorization data, we have to provide the store ID along with authorization model ID. Okay, cool. So first of all, we have to validate the store ID is not empty, authorization model is not empty, relationship is not empty. So I added some validations here. And once everything is fine, first of all, I have to define the store ID, obviously. And then I define the relationship for the user. Yeah. So what user, what is the target, what is the user, who is the user, yeah, the target object and the relation here. So as we can see, once I define this relation, I can use OpenFGA client.write. And here is the write request, and I have to define this tuple keys instance. So here I'm stating that the user, and this is exactly what we saw in our playground. So user Daniel, so here there is the user and the relationship user, is in the relationship type, which we have to pass to the API. So from the playground, this is this one, yeah. The user is in relation, such relation, with the object document, and here we have to pass the target object. So from the playground, it's our folder 01 or document 01, yeah. And once we define it, this relationship, this tuple, is saved. And then here it will basically land. So let me open that really quickly. You can see that we, under public.tuple table in our database, we have different kinds of relationships. So here we can, for instance, see that user with such ID, which I will explain in a minute, is in a reader relation to the doc01, and the object type is document. Again, the same user is the owner for document 02. Yeah, so we can see those relationships in the PostgreSQL database that is connected with our OpenFGA server. Perfect. So the last method is to check the relationship. Yes. So obviously some validations again to check whether store ID is not empty, authorization model is not empty. And once it's done, here we are doing the check request. So OpenFGA.check. And here we have to provide the tuple key. So it's nothing else than, as we saw, the assertion. Yeah, like, let me get back. Check whether this object, this user, sorry, has this relationship with this specific document, this specific object. And then we have to also provide authorization model ID, obviously, and store ID, yeah, at the top. It's very important. And for one more thing, when it comes to performance, it's recommended to always add authorization model ID. So if you will open OpenFGA documentation and section called perform a check, somewhere there, oh, sorry, yeah, it's here. So you will see that you should always specify authorization model whenever possible. Yeah, it will just increase the performance when it comes to OpenFGA server. Okay, perfect. So right now we can check whether specific user has a relationship with specific object, and as a response, we will get true or false. So it's really simple because we are asking, okay, does user Daniel have this owner relationship with the document doc01? And then you will get true or false. So exactly as you saw here in the playground. Yeah. So this is why we see is allowed, true, false. So it's really simple because then if I will ask whether a specific user has specific permission to access specific resource, then it will be there will be only one property return. Yeah. So let me show you that really quickly. Yeah, there is the response allowed. Yeah. So as you can see, if we will go to implementation from the OpenFGA. Oh, sorry. Yeah. So here, as you can see, there will be this allowed property used, and it can be true or false. So simple check. Do you have permissions? Yes, no. That's it. Okay, perfect. So obviously, once the OpenFGA authorization manager is configured, as you saw here, then I can obviously expose it using the ASP.NET Core Web API. Yeah. So in the real world scenario, you can imagine that you will have the API that will be responsible for creating stores, creating authorization models, and other things. And on the other side, you will have set of APIs to define relationships and check the authorization data. So that's why here I have this controller created, authorization data controller, and here I have all those methods to create authorization stores, to create authorization models, to create relationships, and also validate those relationships. So once I have this API, it's also exposed in the Azure cloud using Azure Container App, but the separate one. And now I can communicate with this API, and this API internally will communicate with OpenFGA. So that's why I mentioned that in the production scenarios, you can even hide OpenFGA server in the Azure cloud. So you can disable ingress. So it will not be possible to communicate with this OpenFGA publicly. And then from another component in your solution architecture, like Authorization API, you can securely communicate with OpenFGA server. Perfect. So right now it's time to see this in action. So as I mentioned here, let me really quickly go to the authorization model. So as you can see, in our sample, we are using this model. Yeah. If I will click Save, you will see that, folder not found. Okay, because I have this tuple here. So let me remove it. Let me remove those tuples and then let's see. And even if not, I will create another test store just to show you the visualization. Yeah. So this is a simple model we use in our demo here. So there is authorization store, we have user, we have document, and user can be writer, reader, or owner. So like user can have this relationship to the document as reader, writer, or owner. So now we will check how this authorization can work from another perspective, so from the application perspective. So this is why for that I created Blazor application, ASP.NET Core Blazor application that we will use to check how authorization can be handled on the application side. So let me open this project right now. Here is the Blazor application open in the Visual Studio. And as you remember in my presentation at the beginning of this video, I mentioned that there are two approaches, like token-based authorization, yes, and also the global authorization system-based approach. So in this case, we are talking about the second one, and there is always this question, okay, so how how to perform this authorization check, how to integrate this application, yes, to make sure that we can handle authorization data every time there is a request sent to our application. So that's why I decided to show you that from the Blazor web application perspective, to also see what is happening on the UI front, like what is happening from the user perspective. But this approach can be also used in the ASP.NET Core Web API. With all different kinds of endpoints you want to secure with OpenFGA. So before we will start, let me really quickly open the Azure Data Studio to make sure that we can see the defined model and relationship, to be more specific. So as we can see, here I have three records. As you can see, here is the user, and there is this magic GUID. This identifier. So I want to show you that really quickly. So here is the Azure AD B2C blade and a specific user profile opened. So for this specific scenario, what I will use Azure Active Directory B2C to secure my Blazor web application, to make it possible to authenticate users. And once those users are authenticated, then we will use OpenFGA to check the authorization data for those users. The important thing is that, as you can see, for this specific user, which is Daniel, me, under object ID, we have this unique identifier. This is unique identifier of the object within this Azure AD tenant. So it's really, really important when you will define the authorization data and authorization relationships to use those unique identifiers. So I strongly recommend, instead of using email, to use the object ID. So that's why in the Azure Data Studio, in the public.tuple database, in the table, we have this user and the identifier of this user used. Because in this case, every time I want to connect some data with the user, I will use this object ID instead of using email or some other properties of the user profile. Perfect. And the same is for other documents, yes? Like doc01 should be also unique, doc02. I mean in a specific context, but this is just an example. The most important thing is about the users. Okay, perfect. So right now, I stated that this specific user with this specific object ID, this user from the Azure Active Directory B2C, will be able to access and to manage document doc02 and 01, yeah, because this user is the owner for this specific document. So right now, let me show you this Blazor application really quickly. This is this application, and here let's sign in. So I will click login, yeah, and here is the login page of the Azure AD B2C. I have to provide the credentials for this specific user, so let me do it really quickly, and I will click sign in button. And after a few seconds, I'm redirected to the application. Here is the greeting, hello Daniel. And then I can click confidential data tab, yeah? And as we can see, after the few seconds, there is information displayed. You are authorized to see confidential data view thanks to OpenFGA authorization. So in this case, I can log out, click login button again. And now let's use another user account here. So I will sign in. And after a successful authentication, I'm able to open the application. We can see the greeting here. And now when I will click confidential data, we can see information forbidden. You cannot access confidential data view. You are not authorized. So as we can see, authorization worked. So right now, let's discuss the details, what's happening underneath when it comes to this authorization system. This is the authorization API that I created in the ASP.NET Core, as you remember. And I integrated this API with OpenFGA using OpenFGA SDK for .NET. So right now, this authorization API exposes those kinds of endpoints. to create authorization store, to create authorization model, to create authorization relationship, and also to check the relationship. So this last endpoint will be used in the Blazor application to check whether a specific user is authorized to access specific view in the web application. So now let's investigate what is happening in the Blazor application source code and how authorization is handled. Here is the Blazor web application open in the Visual Studio. Let's start with the configuration. In the app settings JSON file, you can see that I have authorization API configuration section, and here I have to provide three parameters. URL to call authorization API, authorization store ID, so the ID of my authorization store, and the ID for the authorization model I created before. And obviously you can ask the question like, okay, Daniel, but what about the secure communication with this authorization API, which is ASP.NET Core Web API integrated with OpenFGA? This is out of the scope of this video, but obviously this communication should be also secure. So in this specific scenario, you should not publicly expose this authorization API so everyone can call it. So that's why it's better to integrate this on the API side, and then every time you call your web API endpoints, then there is a check against OpenFGA, and then you decide whether application should receive some data, or the forbidden 403 should be returned with the information that user is unauthorized to see the specific data. But for this specific demo, I decided to use Blazor application to show you that from both perspectives, from the code perspective and also from the end user perspective in the web application. So all those concepts I will present right now can be applied in the ASP.NET Core Web API project. Okay, perfect. So let me close the configuration file and let me open authorization folder, and let me show you two classes. Relationship requirement class, which implements authorization requirement interface, and relationship authorization handler, which derives from authorization handler with relationship requirement. So here we can define relationship requirement. So we can say that we require specific relationship between the user and object to authorize the user to access specific data. So we will see how to do it. But the case is that for this relationship requirement, we have one property, string relationship type. So here we will define the relation type between user and the target object. Now in the handler, we will do the authorization check. So let me show you what's happening here. So in my relationship authorization handler, I have authorization API service, which I will show you in a minute, and I have authorization configuration parameter here. So authorization API configuration and authorization API service. And now, as you can see, we have to override this handle requirement async method, which is declared in the authorization handler from which we derive in this specific scenario. So right now, let me put it here to make it more visible. So right now, let's discuss what's happening in the handle requirement async method. So we have to pass the authorization handler context here. So the context in which this specific application or API is called, and also the relationship requirement here. So let's discuss what's happening there. First of all, when the request is sent to our web application or ASP.NET Core Web API, it doesn't matter. This concept can be used in both. Here, first of all, we have to extract the user ID. This will be extracted from the ID token that is returned from the Azure Active Directory B2C, because this Blazor application is secured with Azure AD B2C. Once I have this user ID, I have to check if it's not null. So I have to check if there is user context. And if it's not null, then I'm creating this object called authorization relationship request. Let's see really quickly what's happening there. As you can see, in this request, I have to provide the authorization store ID, the authorization model ID, and authorization relationship, which is user, relation, and target object. So here I will ask Authorization API. Hey, Authorization API, please check against the store with this ID and authorization model with this ID whether this specific user is in this relation to this specific target object. So now if I get back to the class, you can see that here I'm asking the question, okay, please check whether this user with specific ID, which is the object ID of the user from Azure Active Directory B2C, check whether this user can access doc01, so document 01, and whether this user has this specific relationship, so relation type. So in this specific scenario, we will declare this relation type, and it's taken from the requirement that is passed as a parameter to the handle requirement async method. We will see how it's done right now. But the most important thing to remember here is the fact that in this handler, we have to call Authorization API and ask, hey, Authorization API, could you check whether this specific user is in this specific relationship to this specific target object? And obviously, we will have the response from the Authorization API, and we have to check whether it's successful. And if it is, then we have to deserialize the body, and we will get the operation response result, and we will check the is allowed property. So here, authorization relationship response will return only is allowed set to true or false. As you remember, we mentioned that OpenFGA will just respond with this simple information. Is the user allowed or not allowed? So in this specific scenario, we will get this information. And if operation response is not null and user is allowed to prepare or perform specific operation, then we will set context as succeeded. So this requirement we specified above is compliant. Yeah. So then we succeeded. So user can access this confidential data tab. And obviously this is just a simple code. Some logging should be added here, some secure communication with Authorization API, as I mentioned before, but this is just for brevity. So as you can see, I'm extracting user ID from the token in my web application. I'm checking whether it's not null. I'm defining the request to the Authorization API to check whether user is authorized to access specific resource and in which relation type. And then I'm getting the response from the OpenFGA. Perfect. So right now, let's see how it can be integrated within the application, because great, we have relationship authorization handler class, but now let's open program.cs class and let's see what's happening here. So, as you can see, there are different kinds of middlewares. So again, as I mentioned, this concept can be also applied to the ASP.NET Core Web API. I used Blazor to show you the whole scenario from the user perspective in the web application. Here, I have this section called Add Authorization Services. So let's go to the implementation. So here, as you can see, I'm adding authorization to my web application, my Blazor web application. And here I'm specifying the policy. So it will be policy-based authorization in this Blazor app. Yeah. So as you can see, I have to provide the name of the policy and configure it. So in this case, I'm saying that reader relationship is required. So I'm calling this policy reader relation required, and I'm configuring this policy. I'm adding requirements. In this case, new relationship requirement, which is reader. So that's why then in our relationship authorization handler, when application will call a handle requirement async, this relationship requirement I'm specifying here in this specific class. Let me open it really quickly once again. Reader, this information will be passed to the authorization handler in this requirement here, this relation type. So in this case, I want to check whether it has reader relationship to specific document 01. And obviously then I'm registering the relationship authorization handler and I'm adding HTTP client here because authorization API service is the class to communicate with this authorization API I showed you before, in a minute before. So here there is one method, check authorization relationship. Here I have to provide the URL to my authorization API. This is the endpoint, check relationship, and then I will get the response. So now let me close it and let me show you the confidential data Blazor component. So here, as you can see, this is the confidential data page for our Blazor application. And here I have this authorized view. And here under authorized view, I set this policy. User can access this specific page under condition that reader relationship is compliant. Yeah, like if user can read the document, so if we will check against OpenFGA that a user is in the reader relationship to the document that we specified, then user will see this view. You are authorized to see confidential data thanks to OpenFGA authorization. But if user is unauthorized, is not authorized in this case, we will see information forbidden. You cannot access confidential data view, you are not authorized. And obviously this is just a simple example, yeah, like with the policies. But please remember that you can be more granular here. So you can specify different kinds of documents, get their identifier. So let's say that you store different kinds of documents in your database. Each of the documents has its own identifier, and then you define this relationship. Like, okay, this specific user from the Azure AD B2C with this object ID has this relation type, like writer-reader, to this specific document with this specific ID, like unique GUID. And then when user will try to access specific section within your application, you can just ask authorization API, okay, before we will do it, let's check whether this specific user is authorized to this specific document. So this is why you can see it's pretty straightforward. So I'm adding this policy here. And then every time I will call this page, I will open it, the reader relation required policy will be executed, and then relationship authorization handler will be executed and handle requirement async method. This method will call OpenFGA authorization API, and once we have response, we will decide whether user is authorized or not. So perfect. So right now we understand how it works. So let's enable here this application once again to see it in action in the debug mode. Here is our Blazor app. I will click login button. User is redirected to the Azure AD B2C. Here I have to provide credentials. And then I will click sign in button. And then I will click confidential data page. So as we can see, here I have the breakpoint in the handle requirement async method. So we have to check the user ID. And as we can see, this is the unique identifier of the user in the Azure AD B2C tenant. So now if the user is not null, it's not empty, we will prepare this call to the authorization API. So here we want to check whether user with this ID has the reader relation to the target object, which is document 01. And then we can call the authorization API and we got the response. So operation response is completed with success, and under result we can see that is allowed is set to true. So then if I will click continue, we can see that I am authorized to see confidential data view thanks to OpenFGA authorization. The last two things I want to show you. The first one, best practices of managing tuples and invoking APIs when it comes to OpenFGA. So first of all, do not store any personal identifiable information in tuples. This is very important, yes? It's not the place to store any personal identifiable information. In the tuples, we should only store information about the relationship between objects. You should always specify authorization model ID whenever possible. This is to increase the performance. And if listing list objects, avoid having intersection or exclusion in the authorization model. So I recommend you to check best practices of managing tuples and invoking APIs section in the OpenFGA documentation under openfga.dev. And also, the second thing I want to show you, here is the information how to interact with the API. Yes, so how to manage user access, how to manage group membership, how to get tuple changes and so on. So there are different kinds of examples how you can use this OpenFGA API, of course, including SDKs like SDK for .NET. Perfect. Thank you so much. I hope that you enjoyed this video and you found it interesting and helpful. And fingers crossed for your implementations with OpenFGA authorization. Thank you so much for watching.